back to more fun with math with Mr. Massey. Today we're going to be talking about complex numbers, aka imaginary numbers. So I'm going to give you a quick rundown of what to expect on the homework in case you missed one of these lessons, alright? So real quick, when we're talking about complex numbers, normally we're talking about finding the square root of something, alright? So when we're finding the square root, we're thinking to ourselves, what number times itself gives me this guy under the radical? So the square root of 9 would be I heard a positive 3, because 3 times 3 gives me 9. So what number times itself gives me 9? That's going to be a 3. But also, we know that a negative times a negative gives me a positive. Yeah, I think I heard that too. So here, the square root of 9 could be a positive 3 or a negative 3, because negative 3 times negative 3 still equals positive 9. So with that being said, and that fresh in your mind, what's the square root of a negative 9? What number times itself equals a negative 9? Well, it can't be positive 3 times positive 3, because that equals positive 9. So it definitely can't be positive 3. Definitely can't be positive 3. Can't be negative 3, because negative 3 times negative 3 equals positive 9. So what are we going to do? If it's not positive 3 and it's not negative 3, that means we have to create a number to solve this. We have to create an imaginary number. So what we're going to do to solve this one is we have to create an imaginary number to make this work. So we're going to keep a placeholder for that imaginary number, and that's going to be called I. Alright? And our I is always going to equal the square root of negative 1. The square root of negative 1. I know you're probably thinking, Mr. Massey, you're confusing me already. Nah, no, I know. Hold that thought. I'm going to show you how this works right here. Whenever you see a negative underneath the radical, I want you to think about this. I want you to build a little tree, and I want you to split up this radical. So instead of the square root of negative 9, I want you to split up these radicals by factors of negative 1. So when I ask you the square root of negative 9, immediately I want you to chop it up into the square root of positive 9 times the square root of negative 1. Because this here is the same thing as the square root of negative 9. From here, it makes a little bit more sense. You know the square root of negative 9, what's that? Plus or minus 3. Yeah, that's going to be a plus or minus 3. You told me that up here, right? Positive or negative 3. Now this little guy, the square root of negative 1, the square root of negative 1 is always going to spit out an I. An I right here. That's my imaginary number. That's how I'm going to make this thing work. Since there's no one number that multiplies by itself to give me negative 9, I'm going to invent one. I'm going to imagine it. So here, this 3i, this plus or minus 3i, is my answer to the square root of negative 9. This 3i is my imaginary number. Right? So that being said, let's fly through this example over here and see if we can't connect the dots and figure out these puzzles, all right? So example number 2, right in our face, is going to be the square root of negative 64. Well, off the bat, I want you to split this guy up. So instead of the square root of negative 4, I want you to think the square root of 64 times the square root of negative 1. Yeah, awesome. All right. So here, this makes our life a little bit more manageable. It makes things a little bit more familiar. It makes this makes solving this much easier. All right. So here, the square root of 64, walk in the park. What is it? Plus or minus 8. Yeah, you in the back. Plus or minus 8. All right. The square root of negative 1 always spits out an I. Yeah, I feel it. I feel the excitement. So the square root of negative 64 is plus or minus 8i, our imaginary number. All right. Brings us to example number 3, the square root of negative 48. What is it? Hold up. Well, this is going to be a tricky one because there is no square root of negative 48, so we got to dig into the bag of tricks here. So this one, I want you to split this one up the same way, make our little tree. So instead of the square root of negative 48, I got the square root of 48 times the square root of negative 1. All right? So check this out. I know that this guy spits out an I. Yeah, all right. This guy, though, I want you to think about chopping this one up in a similar fashion. What I'm looking for is I'm looking to chop this guy up into factors of 48, and I'm looking for a perfect square that will spit me out a whole number out of the radical. All right? So check this out. Let's zoom in. Let's get nice and cozy. So here, I can chop this up into my factors. I can chop it up. I can say 1 times 48. I can say 2 times 24. I can say 3 times 16. I can say 4 times 12. And I can say 6 times 8. These right here are all my factors of 48. So I just took radical 48 and I split them up into 2 factors all the way down. So radical 1 times radical 48 is the same thing as the square root of 48. Now what I'm looking for is I'm looking for a perfect square. In this case, this box right here, scoop, has a perfect square, and that perfect square is 16. Can you guys see that? Over here, he's a perfect square. Now, when I have this 16, I can break them up a little bit. What's the square root of 16? Plus or minus 4. Excellent, plus or minus 4. So what I'm going to do is, this guy in orange, I'm going to split him up. All right, I'm going to split this guy up. What I have is, I have the square root of 3. If you guys can see that, I have the square root of 3, right? And you told me that the square root of 16 is simply plus or minus 4. So, I have 4 times radical 3. Right here, I just simplified that guy. And I can't forget about my I, right? So this right here is going to be my answer. This guy right here is going to be my answer. Now, what they want you to do normally is they want you to tidy this thing up, simplify it. In complex form, they always want you to put the real number first, then your I, and then your radical. So, what I'm looking for my final answer is this guy here by the stars. You got your real number, your imaginary number, and your radical. 4 times I times radical 3. That is the simplified version of this. So if I ask you to find the square root of negative 48, what I'm looking for is this right here. Scoop. All right, we got 2 more and we're home free. I'm going to try to get this guy done in under 10 minutes. All right, so now we're going to speed this one up. We're going to go on overdrive real quick, see how fast we can do this one. So off the bat, I'm going to split this guy up into radical 72 times the square root of negative 1. I just took this radical and split them up. All right, now I got to bring down this 5. He didn't go anywhere, so let's bring him down. All right, well, I know off the bat that this guy spits out an I. Yeah. This guy right here, I'm trying to split him up into factors. So I got radical 1 times radical 72. I got radical 2 times radical 36. Do I got any 3s? Yeah. What do you got? 24. Yeah. All right, just for the sake of time, I'm going to stop here because I've found a perfect square. And that's going to be this fella right here. Radical 2 times radical 36. All right? So, I'm going to move this 5 down a little bit further so I don't forget about him. I'm going to kick this 5 down a little bit further so I don't forget about him. All right? Now, I'm going to simplify this part right here. I got the square root of 2, which is this guy in the box, right? Times the square root of 36. What is that? That's 6, right? Then I got times I. So here, this bottom row of my tree is my final answer. All I got to do is make sense of it. So, if I'm multiplying straight through, the order does not matter. However, if I want to get it in the standard form for my final answer, I want real number, imaginary, radical. So let's see what I got. Looks like these two are my real numbers, 5 and 6. So what's 5 times 6? 30. Yeah. So there's my 30. Here's my little I, my imaginary number. Then I got my radical last, radical 2. This is going to be my final answer for example 4. You guys okay with that? Yeah. All right, we got one more. We're home free. So these first 3, I've simply... Poor choice of words. I've simplified these. I've simply simplified them, all All right. Number 5, we're actually going to put this into an application and solve an equation. So without further ado, Johnny, let's see what we got. So first things first, whenever we're solving an equation, I want to get all my real numbers onto one side, all my variables onto the other, and simplify it down to the furthest form. All right? So let's see what we got. First things first, I got to get rid of this 18. What's the opposite of positive 18? Negative 18. What I do to one side, I got to do to the other. Yeah. So these cancel out, leaving me with x squared equals the negative 18. X squared equals negative 18. All right. So here, I want to get x all by himself. So I want to get rid of this little exponent. What's the opposite function of x squared? The square root of x. Yeah. So here I'm going to square root one side. What I do to one side, I got to do to the other. Yeah. All right. So let's do over here. So now, what I have is I simply have a regular x on one side, and on the left, I got to split this guy up with my little tricks, right? So I got radical positive 18 times square root of negative 1. This spits out an I always. This guy, I got to chop him up. So I can chop him up as radical 1 times radical 18, radical 2 times radical 9, radical 3 times radical 6. All right, pump the brakes right there. I found him. It's going to be this guy, radical 2, radical 9, because 9's a perfect square. What's the square root of 9? 3. Yeah. So it looks like I got a 3, right, out of this guy. Looks like I got my I, then I got my radical at the very, very end, right? So here, since I'm actually solving an equation, my answer is going to be x equals this simplified version over here. Scoop. All right. So just like that, we're off to the races with our complex and imaginary numbers, and the crowd goes wild. All right, guys, I'll see you all in class. Do your homework, love your family, read a book, practice these complex numbers. They're on the SAT.